The purpose of today's lesson is dilations and proportionality. When an object, such as a line, is moved in space, it is called a transformation. A special type of transformation is called a dilation. A dilation transforms an object in space from the center of dilation, usually the origin, by a scale factor called r. Scale factor called r. The dilation moves every point on the object so that the point is r times away from the center of dilation as it was originally. This means that the object is enlarged or reduced in size. So transformation means to reduce or enlarge in size. That's what we got from that. And it is reduced or enlarged by a scale factor of r. That's what all that means. For example, if you dilate the set of points, all of these, with a scale factor of 2, and the center of dilation is at the origin, the distance of each point from the center will be 2 times as long as it was originally. Algebraic, this means that you multiply each point by 2. So if you start with xy, then you end up with twice x and twice y. To confirm this, investigate this transformation below. Okay. Graph and connect the ordered pairs 0, 0, 0, 4, 3, 0, and 3, 4. Okay. So here, I'm going to make this thicker. It makes it much easier to see. Here we have 0, 0. Then we have 0, 4, 3, 0, 1, 2, 3, and 3, 4. Graph and connect. Okay, so now I'm going to connect these points. And I'm going to end up with a rectangle. Okay, so far so good. Then the next order of business is, it says, find the length of each segment and dilate it by a scale factor of 2. Draw and label the new lengths. Okay. So let's go red. Let's see, this one is a length of 4. This is a length of 3. So I have to double that. So that means this should be, let's go ahead and make this a little thicker. This should be, instead of 4, we're going to go up 8. 5, 6, 7, 8. So this new one is going to be here. This, instead of 3, is going to be twice that, and that's going to be 6. So that's going to go all the way out to here, here. And then we would just connect all of these. So what we've done is we've just doubled the size of this. And we did it in a different color. Okay? Then let's look and see what we have here. We have some more definitions. We've got the original object is called the pre-image, and the transformed object is the image. So the pre-image I did in, what color did I start with up here? I started with blue. Okay, so the pre-image was in blue. Okay, sorry about that. So the pre-image was in blue, and then the image, what we ended up with, is in red. So that was our drawing. Okay, then the next order of business is, it says, compare the size of the pre-image with the image. Well, each side is twice the length, and the area is, well, let's see, this one is 3 by 4, so this area is 12, and this one's going to be 8 by 6. 8 by 6 is 48. So the side lengths are doubled, and the area is 4 times the size. So that's what happens to the area. Okay? Dilate by a scale factor of 2 algebraically using the ordered pairs. Okay, so now we're going to take the 4 points and we're going to multiply both the x and the y by 2. So we have to take each one of these by 2. That's the scale factor. And we're going to write our new ordered pairs. Okay, so this one doesn't change. That stays 0, 0. This becomes 0, 8. This becomes 6, 0. And this becomes 6, 8. Write the ordered pairs. Okay, graph and connect your new ordered pairs. So let's plot our new ones. And 0, 0 is here. 0, 8 is here. 6, 0 is here. And 6, 8 is there. What do you observe about the transformation when you do it graphically and algebraically? Does it matter? No. Both times you end up with the same image. End up with the same image. Remember, the image is what you end up with. Same new image. How do the lines that correspond to one another in the image and pre-image compare? Well, the slopes are the same, and the lengths are proportional. Because what happens is they were doubled. They were doubled. Okay, let's take a look at this next one. A special notation is used to differentiate between the pre-image and the image. If the pre-image is called A and the image is called A prime. Okay, try another shape to see what kind of relationships exist between the pre-image and the image. So go ahead and graph these and connect the ordered pairs, and then you're going to find half of the lengths. So I'm going to pause it and you plot the points and I'll... Okay, did you get this for your drawing? Okay, now we're going to halve it. H-A-L-V-E. We're going to take it by a scale factor of 1/2. So we have to take half of 3, which is about 1.5. That there. They tell us that the hypotenuse, which is this length here, is 5, so that'd be about 2.5. And then what we have here is half of 4, which would be 2. So it would be right there. So we're going to connect these, and that is going to be half. So label the pre-image A and the image A prime. So the pre-image is A, and that's my red one. So this guy is A. The pre-image is A prime. Okay, compare the size of the pre-image with the image. The pre-image. So each side of the image is half of the pre-image. What do we know about the area? What do you think? What do you think the area? I'm going to leave that and see if you can come up with. What do you think it's reduced by? Okay, dilate by a scale factor of 1/2. Now we're going to do algebraically. So we're going to take each point and then we're going to halve it. So write the 3 points, 0, 0, 3, 0, and 3, 4. And now we want to take each one by 1/2. That should be times a half now. Divided by. So this one doesn't change. We get 0, 0. Half of 3 is 1.5. Half of 3 is 1.5, and half of 4 is 2. Get that out of there. Okay. So now we're going to plot, write the ordered pairs, graph your new ordered pairs for the image. Let's go ahead and do that. Okay, I went ahead and plotted those. What do you observe about the transformation? What do you observe about the transformation when you do it graphically or algebraically? Same thing both times. Same thing both times. You end up with the same thing. How do lines that correspond to one another in the image and pre-image compare? So they have the same slope, and the lengths are proportional. Same as the previous one. Proportional. I'm not going to write all that out. Okay. This concludes our lesson on dilation and proportionality.